Right, in this particular lesson, what we're going to be looking at is simplifying factored rational expressions. So these rational expressions will already be factored. One important thing, so there's two steps, or two key ideas, is to simplify factored rational expressions. One thing you have to do before you start dividing by common factors is state the non-permissible values, or what we have been calling NPVs, before you simplify. And after that, all we do is divide the numerator and denominator by any common factors. In this first example, so we'll just do a few examples. In this first example, some of you may be able to do it instantly. For others of us, we may want to actually do factor 12 and 9 and write this out in its entirety. So if you'd rather rewrite the numerator, 12 in its prime factorization is actually 2 times 2 times 3. X squared is 2x's, and y is itself. So in that particular case, that is your numerator, if you'd like to write it on its entire factorization, and your denominator 9 is equivalent to a prime factorization of 3 times 3, and that's times x times y. Before we continue, first of all, we have to state our non-permissible values. Our non-permissible values in this particular case is related to the x cannot equal 0, so that's one of our non-permissible values, and related to our y, remember non-permissible values are only related to the denominator, y cannot equal 0 because that would give us a denominator of 0 and you cannot divide by 0. Now we can start simplifying. All we need to do is divide all of our common factors. So you can see in this numerator we have a 3, denominator we have a 3. We can cancel those out or divide them out. These x's can be canceled out and these y's can be canceled out. So our numerator is left with 2 2's and an x, which simplifies to 4x, and our denominator simplifies to just 3. So simplest form is 4x over 3, or 4/3 x. In our next example, let's deal with the non-permissible values first. Our non-permissible values related to 9x is that x cannot equal 0. And our non-permissible value related to 2x plus 3 is that x cannot equal negative 3/2. If you're not clear on how to come up with that non-permissible value, maybe look at the non-permissible value lesson. That is as a YouTube lesson already. So let's start simplifying. What some people may again be helped by doing is doing the prime factorization for the monomial factors. So 6x is equivalent to 2 times 3 times x. And 9x is equivalent to 3 times x, and we can just leave that binomial factor of 2x plus 3 alone. That can't be factored any further. So if we divide out any common factors, these 3's can be divided out, these x's can be divided out, and nothing else can be divided out. So just to be clear, this 2 here cannot be divided out with the 2 in the 2x plus 3 binomial. The entire factor has to be the same in order to divide it out. So in this particular case, we're done simplifying. In our numerator, we have 2. In our denominator, we have 3 times 2x plus 3. So our simplest form is 2 over 3 times 2x plus 3, and that is it for that particular example. In our next example, our non-permissible values, again, non-permissible values being related to values for the variables that would make the denominator equal 0. Our non-permissible values are that r cannot equal 1, because that would give the first factor value 0, and r can also not equal negative 8. Now, in order to simplify, these are already factored entirely. There's the monomials can't really be factored much more whatsoever. So what you can see is that these common factors of r minus 1 can be divided out. However, once again, you cannot divide this 8 with that 8 because the first 8 is a monomial and it's not common with a binomial factor of r plus 8. So you cannot divide a monomial with a binomial. So your simplest form here is just 8 over r plus 8, and that is that. In your last one, what we have is, let's deal with all of the non-permissible values first. We have 3 factors in our denominator, and each factor has a different non-permissible value. Our first factor of 2x minus 5 has a non-permissible value of 5/2. Our second factor of x plus 4 has a non-permissible value of x cannot equal -4, and our factor of x minus 6 has a non-permissible value of x cannot equal 6. Those are our non-permissible values. And finally, in order to divide our common factors out, which these are already factored completely, x minus 6 can be cancelled out with or divided by x minus 6, and in this particular case, if we look and inspect carefully, there are no more common factors. 2x cannot be factored or divided out with 2x minus 5. Those are totally different factors. 3x plus 4 can also not be divided out with x plus 4. Those are totally different factors, even though the 4's are the same. The binomials are different in and of themselves. So in this particular case, the simplest form is 2x times 3x plus 4 all over 2x minus 5 and x plus 4. And that is indeed the simplest form.